A regular hexagon of side 10 centimeter has a charge 5 mu coulomb at each of its vertices. Compute the electric potential at the center of the hexagon. So we have a hexagon which is of side 10 centimeter and it has 5 mu coulomb at every vertex. Now we have to find the electric potential at the center. So yes, what is the electric potential due to point charge? That is kq by r. So here we can see there are totally 6 charges which is of same value, that is 5 mu coulomb. And also we know potential is not a vector quantity, so it is a scalar. So we know we don't want the direction. So because of this point charge, what is the formula, what is the potential? That is k into this q by r. What is the r? This is this distance. Okay, this distance is r, because this is the point which is at a certain distance from this charge q, and we have to find the potential at this point. So this is the distance between that charge and this point, so that is small r. So that this will be kq by r. Okay, now we know all the charges are at same distance from the point o, that is all the charges are at the distance r from point o. So we can take just we can add it. So how many charges are there? 6 charges. So 6 into kq by r. So that is the answer. So 6 into yes, what is k? That is 1 by 4 pi epsilon naught. So this is actually 9 into 10 power 9. And what about q? It is 5 mu coulomb. That is 5 into 10 power minus 6. What is r? It is 10 centimeter. So we have to convert it into meter. So it is 0.1 meter. So the answer is 2.7 into 10 power 6 volts. A spherical conductor of radius 12 centimeter has a charge of 1.6 into 10 power minus 7 coulomb distributed uniformly on its surface. What is the electric field inside the sphere, just outside the sphere, at the point 18 centimeter from the center of the sphere? So there is a spherical conductor and its charge is distributed uniformly on the surface. So it will be like this. Now its radius is 12 centimeter and it has a charge of 1.6 into 10 power minus 7 coulomb. So what is the electric field inside the sphere? As inside there are no charges, the electric field will be 0. Just outside the sphere, so just outside the sphere means it is almost equals to the radius. So what is the electric field? It is kq by r square, because this is the formula for electric field due to point charge, right? So this is same, we can assume here as if all the charges are assumed at the center, so we can use this formula. So what is the answer? It is k, that is 9 into 10 power 9. Q, what is q? It is 1.6 into 10 power minus 7 coulomb. What about r square? It is the radius square. 12 centimeter means it is 0.12 meter, so 0.12 whole square. So that is the answer. So at the point 18 centimeter from the center of the sphere. So from the center of the sphere, we are going to take a point. Suppose here it is the point P, and which is at 18 centimeter. So there is 0.18 meter. Then what is the electric field at that point? So again same formula. Here you are going to use k cube by r square. So here previously we have used capital R, but here now we should not use that. Now we have to use the small r, which r is greater than capital R. Okay, what's the answer? 9 into 10 power 9 into what is q, and by the distance. Okay, the point P at from the center of the sphere, what is the distance between them? You have to take that distance. So it is 0.18 whole square. So that is the answer for that question. A charge of 8 millicoulomb is located at the origin. Calculate the work done in taking a small charge of minus 2 into 10 power minus 9 coulomb from a point P to point Q via point R. So there are charges like at origin we have Q is equals to 8 in 8 millicoulomb. So we know because of this Q, there will be a potential at point P and potential at point Q, that is kq by r. So there is a value of potential at these 2 points. Now we are bringing in another charge, that is minus 2 into 10 power minus 9 coulomb, and we are going to take it, we are going to move that charge minus 2 into 10 power minus 9 coulomb from point P to point Q through point R. So they are asking us what is the value of work done. Now please note, work done in electric field, that is path independent. Okay, so whether you take it directly from P to Q, or you make it go to R and Q, whatever may be the path, the work done is same. Okay, it is independent of path. So what we should do, we already seen this one. What if we move a charge from one point to another point in an electric field which have two different potentials? Okay, suppose this is the electric field, and this is one point, that is P, and this is another point, that is Q, and we are going to move a charge Q, small q, from P to Q. Then what is the work done? Work done is equals to Q into V final minus V initial. So what is V final here? That is VQ minus what is V initial? VP. So this is what is the formula to find the answer. Now we should know what is the V final and what is V initial. That is VQ and VP we should know. So what is the potential at point Q? The potential is because of this charge. Okay, so we have to take this charge and we have to find the potential. Now VQ, what is the potential at here? It is KQ by R. So yes, K 9 into 10 power 9. What about Q? It is 8 into 10 power minus 3. And by what is R? The distance between these two things. That is distance between Q and that is this charge and capital Q. What is that distance? It is 4 meters. Yes, sorry, it is 4 centimeters. So it is 4 into 10 power minus 2 meter. So that is the answer for potential at Q. What about potential at P? It is KQ by R again. K 9 into 10 power 9, Q is 8 into 10 power minus 3. What about the distance between them? It is 3 centimeters. So it is 3 into 10 power minus 2 meters. So the answer is 24 into 10 power 8 volt. So this is the potential at point P and Q. Now we are going to move this charge. Okay, minus 2 into 10 power minus 9 coulomb from P to Q. So what about we have to just substitute the values. What are the values? It is Q, that is minus 2 into 10 power minus 9 coulomb. So this is the charge which we are moving, so we have to use this charge, and we have to take the symbol definitely. Okay, if the symbol is not used, then your answer will not be correct. Then what about V at Q? So V at Q is 18 into 10 power 8. What about V at P? That is 24 into 10 power 8. So just solving it, we are getting 1.2 joule. So that is the answer. If one of the two electrons of H2 molecule is removed, we get a hydrogen molecule ion H2 plus. In the ground state of H2 plus, two protons are separated by roughly 1.5 Armstrong, and the electron is roughly 1 Armstrong from each proton. Determine the potential energy of the system. Specify your choice of zero potential energy. So now we have two protons, that is plus E and plus E, separated by 1.5 Armstrong, and one electron separated from both the protons at a distance 1 Armstrong from each. So this is the system we have, and we have to find the potential energy of the system, and that was asked in the question. Now so here we can take three pairs of charges, plus E and plus E, plus E and minus E, this minus E and this plus E. So that is how we have to find the potential energy. So what is the value formula for potential energy? That is K Q1 Q2 by R. So R12. So depending on what charges you take, the distance between them you have to take. So first let us take these two pairs of this pair of two protons. So it is K, Q1 and Q2 are same, that is E into E by R. What is the distance between those two protons? 1.5 Armstrong. So that is what we have to take. Next we take these two, okay, plus E and minus E by, what is the distance between them? 1 Armstrong. Similarly the next one is also taken. Now we can take K outside, and also this E and E, that is E square, that is also common, we can take it outside. So 9 into 10 power 9 into 1.6 into 10 power minus 19 whole square into, now we have to be very conscious about the sign. So the first one is plus sign only, so it is 1 by, what is the distance between them? 1.5 Armstrong. How do we convert Armstrong into meter? 10 power minus 10 meter. So that is what we have done. So here also there is a negative symbol, here also there is a negative symbol, so please be conscious of that. By, what is the distance here? It is 1 Armstrong. 1 Armstrong is 10 power minus 10 meter. So these two values are same. So on solving, we are getting the answer. So the answer is minus 19.2 electron volt. The zero of potential energy is taken to be at infinity. So we have already seen at infinity the potential that is zero. There is a zero potential.